Welcome everyone to Visualization and Data Exploration. My name is Aseda Addai-Deseh, and I currently work as a data scientist with an insurance company based in the US. But before then, I was in Ghana. I had my bachelor's in computer science at the Kwame Nkrumah University of Science and Technology. And I went on to work a bit with Wave 2 Analytics, which was involved in customer and retail analytics. Between finishing my bachelor's and working at Wave 2, I joined PyLadies Ghana, which is a focus group under the Python Ghana community that tries to help more women become active participants and users of Python. So I actually lead the data science focus group of that. Then also I got involved with Ghana Data Science Summit and Indaba X Ghana Deep Learning Indaba. So back in 2019, I happened to meet the Delali, Austin, and they were starting this out. So I came on board, joined the team, and then helped to pull off our first Indaba X Ghana. And since then, we've been having it almost every year. So I heard you guys talking about deep learning in Indaba. So actually my first deep learning in Indaba was in Nairobi in 2019. And I went there with Deborah. At that time, Deborah was the winner for our poster presentation here in Ghana. And I was representing the organizers in Ghana. So we went over there and then we saw women in machine learning and data science in Nairobi. And we're like, oh, we can have this in Ghana. So let's come back to Ghana and have that. So we started that also in 2020. And this year, we are excited that our number has grown. We've grown so much that we're able to host a Women DS session at the Indaba. So I also went on to have my master's in computer science at Stevens Institute of Technology in the US. And I took more of like data analytics electives. So after that, I got a job with Central Insurance. So that's just a little bit about me. So today we are going to look at why visualization matters. I'm going to make a case for why you should always visualize your data. And then the two use cases where we can use that, which is in data exploration, which we are going to go more into details about. But then for data storytelling and presentation, that's not the focus of our talk today. That's like a separate thing that you can also use visualization for, but I'll touch on that a bit. Then we'll look at the different data types we have and the types of visualization techniques we could use to display them, right? Or to help us understand our data better. Then we look at some visualization and presentation tools. And then I have the small like mini projects for you, which we'll discuss. And probably if the time is not enough, you would go back and look at it yourself and try to think through on how to like come up with data stories and all that. And I know you also have a practical workshop coming up. So probably this project and that will give you a more a good grasp on how to do the data visualization, and also some additional resources that I think you should look out for, especially on data storytelling, which is like another aspect of using visualization. So I'll go into why visualization matters. So I'm sure like me, most of you feel like in data science, like one of the most important things to do is building the models, right? That's like the cool thing. Personally, I used to think that, oh, just give me the data and let me start building models. And when you come from the environment where, I mean, all the toy data sets that we use in learning machine learning, most of them are like well cleaned, well arranged, and for most of them, you can just go into machine learning, right? Because they are trying to teach you the machine learning. They probably don't go much into details as to how you clean, how you get it ready, how you like even try to have a whole overview of your data before you even come up with data stories or stories to tell about your data. But then in real life, I went into my job at Central Insurance, and I realized that data is like so dirty. It's so different from the well cleaned up stuff that you get in school or when you're practicing or when you're taking tutorials and all that. In real life, data is really, really messy, and you want to really understand the data, do some visualization and then do some summary statistics as well as other things, right? So you have to get a good picture of the data to be sure that you are not coming with certain preconceived ideas and then trying to back that, but rather using the data to answer more of your questions. So in exploratory data analysis, some of the things you do are finding like the mean, the mode, the standard deviation, the skewness of the distribution of the data and all of that. And then probably go into do some small visualization and then go into model building. But I want to make a case for visualization that it's not just about the summary statistics. There was this man called Anscombe, and he came up with 4 different data sets, which is now called the Anscombe Quartet. And what he did was that even though he was able to generate 4 different data sets, right? But then they had the same mean, standard deviation, correlation, coefficient, like they had the same, they had the same descriptive statistics, right? The same summary statistics. So you'd be wondering, like, these are different data sets, but until you visualize them, you wouldn't see what kind of patterns or what kind of stories you can tell with them, right? So based on that, another guy called Albert Cairo, he came up with the Thesaurus data sets, right? So it's believed that the Anscombe's quartets, we don't really know how he created his data. So this influenced Albert Cairo, who came up with the Thesaurus data set. So when you see the table, the values, it looks normal, like normal numbers. And even when you look at the mean, standard deviation and all of those things, they look like normal values, right? But when you plot them, you actually see a dinosaur, and that was quite interesting. So you never know what could be hiding in your data, maybe, I don't know, a lion or something, right? So you visualize it, you wouldn't know a lot of what is going on in the data. So also based on the Thesaurus data, Autodesk Research came up with something called the Thesaurus dozen, where they use the same data that Albert Cairo came up with to make the dinosaur, but then they tweaked from the 3rd to the 6th decimal points in the summary statistics we have over here, right? And they ended up creating different shapes. And this, like, if you round them to the nearest 2 decimal points, is the same mean, same standard deviation, same summary statistics, but we are seeing different things playing out here. So I hope this convinces you that it's very important to visualize your data, to just see everything as a whole, and like to have a wholesome perspective on your data even before you get into your machine learning and your model building stuff. So yeah, just to buttress the point that summary statistics helps to explore our data, but we can never trust it alone. We should always visualize our data. So as I mentioned, we are going to look at 2 use cases of data visualization. The first one is for exploratory data analysis. So most of the time, exploratory data analysis, as the name implies, we're trying to explore what's in the data, what's hidden in the data. So it helps us to answer questions with the data. For example, if you have a business problem, right, that you sell ice creams and you're just wondering on which days or in which seasons or times of the year are your ice creams more popular, you can, if you have data on that, you can actually find answers to that maybe on Mondays or on the weekends or on hot days, you have the sale of ice cream going up. Also, exploratory data analysis helps us to explore what questions to ask in the data. Sometimes you might not know exactly what you are looking for. But when you are given, let's say, a COVID-19 data set, right, by just exploring, okay, maybe how many people caught the virus on this date or in which regions and all that could help you come up with stories or with things that you can further investigate with the data. And it also helps us to discover the underlying structure of the data, as I mentioned earlier, and to find patterns, trends, anomalies in the data, and then know how to solve them. So for example, if you have anomalies in your data, you need to start thinking, okay, how am I going to deal with them? Because usually when you're modeling, when you're building your models, you're trying to come up with like an approximation of what the entire data set should look like, right? So if you have anomalies, how will you handle those? So EDA could be done separately or in conjunction with data cleaning, as we can see. And I should mention that it doesn't need to be like a shiny. So shiny meaning like it doesn't need to be perfect, like all the having your title, your axis labeled and all that, because usually it's for further exploration and it's just for internal use for you, the analyst or other analysts who will be looking at it. So the other use case is data presentation or like data storytelling. So in this case, you've finished with your EDA, you've done your model building, you have come up with your insights and you're trying to present it to the business people, right? Or the stakeholders. So in this case, you're trying to distill some aspects of the data into easily understandable charts to convey insights, trying to convince them that your findings are true. And in this case, it needs to be visually appealing, right? So you shouldn't take a visualization straight from Python, Matplotlib, or from R and then just show it to like your business stakeholders. You want to make it more shiny. You want to take it through Power BI or Tableau. You want to have all your labels correct. You want to make sure your colors are all like obeying certain rules of visualization and all that. So I'll touch a bit on the visualization tools, some of them that we have, getting to the end. But I just wanted to state these two clear cases where visualization can be very important. So this aspect is usually done with a presentation software or a dashboard, right? So presentation software like PowerPoint or like Keynote, or with dashboards from Tableau or Power BI, as I have mentioned. So this is an example of a Tableau dashboard for sales, right? For sales performance for a certain product. So if you present this to like a CEO or the chief marketing officer, I know that you're able to tell that, okay, in the West, we are having a lot of sales. So maybe we should find out how we can maintain our lead over there. Or in the South, you're having less sales. So like what's happening? Should we go deep down and dig into why that's happening and all of that? And then see on the right, in the top right, you see the trend in sales, right? See that it's going up. So if maybe something happens and then we see that maybe in 2015 or so, it goes really, really low, like almost zero. That's like an anomaly, or that's like a strange case where we should investigate more to find out what's happening, right? So this is just a snapshot of what a shiny data presentation or dashboard looks like. So before we get into the techniques, right, I want us to briefly talk about the data types we have, because the kind of data you have will determine the kind of visualization you use. So, right, so we can look at data, we can categorize our data into two groups. So the continuous, or like the numeric, and then also the categorical. So usually numbers. So like you can have the height of someone, temperature, like money, revenue, and all of that, and also text, right? The categorical aspects. So for example, like countries, name of countries, colors, and whatever other text that you have, right, that you might want to visualize. So I will go into the techniques. So first we have a histogram, and I'm sure we've all seen histograms before, right? At least, even if it's the first time you're doing data science, you've probably seen a histogram at one point in your life before. So when to use it when we're trying to visualize a single variable or a single data, a single variable, which is numerical, and then one want to see the distribution, right, or the shape, how it looks when we plot it. So maybe you have a class of 100 students, you give them a test, and then you want to know, okay, how well did people do, right, on a graph, and then age as well. Maybe you have like for example, I work in insurance, so let's say age of drivers, right? You want to see the distribution of the age of your drivers in your like your policy holders, right? The distribution of their ages. Are we having more younger drivers or more older drivers? Okay, then yes. Okay, so those are great examples, right? Price of houses in the community over a period of time. Excellent. So you can tell, okay, are we having more pricey houses in this community or not, right? So yes, so there are different shapes. There are various shapes that can help us describe our data, and which we can help us to give us an idea of how our distribution is, right? To know what kind of questions to ask, right? That, okay, for example, are we having more expensive homes in this area, or are we having more younger drivers getting into accidents, like in terms of like insurance, right? And then know what to do from there. So you can visit, all the links I included, you can visit them to read more about histograms and then when to use them and how to use them. So also box plots used to show distribution of numeric data values, especially when you want to compare them between multiple groups. So for a box plot, right? A box plot helps us to, it's also kind of like the histogram in a way, because we spread like the data points to see the distribution, right? But the box plot goes ahead to help us find some of the stuff we'll find with summary statistics, right? Like the mean. So when we divide our data into 4 groups, right? Into 4 equal groups, and want to find the middle points. Once you find the middle points, like the middle point of the spread of our data, that's where the Q2 is, right? And then when we divide like the first part into 2, the first 25%, right? We want to see how many of our values fall within that range. That's the Q1. And then between the Q1 and the Q2, the next 25 is like how many of our values fall between that, and then so on and so forth, right? So you can tell that these other 2 blue points, they do not fall in our range that we are looking at. And since they don't fall in that range, those are considered as outliers, right? So if you have a data set with outliers, you have to start thinking of, okay, what do I do in the case of outliers? Do I want to drop them, or do I want to find a way to incorporate them in some way? So in our distribution, right? So looking at this middle diagram here, we can see that the box parts of the plot is like centered in the middle. So it gives us an idea of how symmetric our distribution is, right? Even though we have a little bit of outliers at the end, we see that most of the data is concentrated at the center point, right? So over here, the last diagram, we see that the box is like pushed to the left. So that's like skewed a bit to the left, right? Even though we have outliers over there. So it gives you a clear picture of the range of your variables, right? And if you have more than one variable, you'll be able to compare the 2 different pictures. Now let's look at scatter plots. So it's used when we have like usually pairs of numerical data. And then when trying to determine whether two variables are related, whether two variables are related in one way or the other. So the example we have here is comparing the sale of ice cream versus the temperature outside, right? So over here, I think we have in the tropics, sometimes it can get very hot, but then it doesn't get too cold. But somewhere in like the temperate zones where there's winter and summer, winter, if you're in the ice cream business, it's probably going to go really low because people are feeling cold, they're trying to get warm and all that. So ice cream sales might not go that high. But then in cases where, or in the seasons where it's very hot, right? Sometimes there are even heat waves, and then they want people to like wear sunscreen and keep cool and all of that, right? People be turning on their ACs and people would want something chill to take. So having a data set like this and plotting it will help you to kind of like find how the two are related, right? So that if you have such a business, you can make more informed decisions as to even the stocking of your ingredients for the ice cream, right? To know when to do that, not to do it in the winter time too much, but then more in the summer to be able to boost or drive your sales. So, the next one we're looking at is the line plots, and it's excellent for tracking changes over time. So if you remember the dashboard I showed you about the sales, you saw that at the top right corner, we're trying to track the sales over time, right? So this is like an exchange rate graph over time. So like from March 2019 to September 2020, like how the change in the exchange rate went over time. So the next is the bar charts, which is used when performing comparison of metrics values across different subgroups. So this is more for the categorical variables, right? So in this example, we're trying to find how many people or how many accounts are in, sorry, this are dollar values. So like how much money, for example, people are putting into check, into the average amount people are putting into check, into credit card, debit card, digital wallets, and cash, right? So so you have a categorical value and they're trying to put them into buckets and then see which category has the most number. So anytime you think of something changing over a period of time, right? Like someone was saying the price of chocolate over like for different months or over a period of time, right? Then that's when the line graph comes in, because you are trying to track, okay, did we sell, how much chocolate did we sell in January? How much did we sell in February, in March, in April, in May, right? That's like over time. But then when it comes to the bar charts, you're having different categories. So let's say we have, so using this example, right? We have data on the average amounts that Nigerians keep in these different buckets, whether cash, digital wallets, in their debit card, credit card, or checking accounts, right? How much people keep there on average. So in that case, you have like different buckets, and then we can plot. So when we plot, we see that, okay, a lot more money, people put a lot more money into their checking accounts than they have on them as cash. So I will move on to the next, which is the pie chart. So also used for categorical variables and used to show distributions of categories as part of a whole. So I'm sure you've all seen a pie chart before. So over here, 6% of total sales per market for small market sizes. So let's say you have a big company and you have regions. You have the West, the East, the South, and Central, right? So just looking at this pie chart, you can see that the West, you have more sales in the West and you have the least sales in the East. But for pie charts, you need to be very careful with pie charts. They are okay if you're using them in your EDA for your own personal analysis. But then in data presentation and data storytelling, it's advised that you avoid pie charts. In fact, one key rule of data presentation is that you try to use as less ink as possible. And as we can see, pie charts, we could have used a bar chart to show this same data, right? But then a pie chart is like taking a lot of ink on the screen. So we try to avoid it as much as possible, and also avoid all those like 3D pie charts and like that's all that is just like extra ink, which we want to avoid. So yeah, so these are some visualization and presentation tools. The good old Excel that we all know. You can do some graphing over there based on some table of data that we have. There's also Matplotlib, which is from Python, which you would go into later on. And there's ggplots from R. There is also Chat.js and D3 from the JavaScript libraries. And yeah, there's also Plotly from the Python libraries. And for the dashboarding tools, there's Tableau, which I've mentioned already, and Power BI, which are also very, very powerful and can give you that kind of like good interface that you can present to business stakeholders. So for the presentation tools, as I mentioned, PowerPoint and Keynotes, this available on Apple, right? Where you put your findings and your insights into a good presentation to deliver to your business stakeholders. Okay, so I put a link to the starter notebook, which is not complete. Yes, right. And then also to the final notebook as well in the drive. So you can take a look at that. So I know you're going to have a lab, like an actual hands-on lab on this. So I'm just going to go over a few things you can do in your EDA, the kind of questions you can ask. And then later on, you can try your hands at all those things, right? And then also think of more questions that you could ask with the data. So before that, you see that I've linked some additional resources in there. So this first link goes to a data camp course, which is very good. It gives you like more understanding on the data types, the kind of plots you should use for what cases you have and all that. And then also this the course I was talking about, data storytelling. It's actually a paid course. It's taught by an ex-Google data evangelist, and it was a good one. I really enjoyed it. And it talked more about finding data stories and then how to present the data to your audience or to the business stakeholders in order to make impact. So that's also a good one you can look at. So this is an interesting project I found on Data Camp. Data Camp has some really good courses and projects which I recommend. Also, their data science courses and projects I've looked at are very good, so you can look at them. So this about the Google Play Store apps and reviews. So I'll try to use like the next 10 minutes to go through, and then I'll leave the rest to you to think about. And then also after your lab session, you can come back to it to see if you can do stuff on your own as well with it. So we all know the Google Play Store, right? So mobile apps are everywhere. They're easy to create. blah, blah, blah. We all know about mobile apps. And we've been given some 2 data sets to look at. So we'll look, says that in this notebook, we'll do a comprehensive analysis on the Android app market by comparing over 10,000 apps in Google Play across different categories. And we'll look for insights in the data to devise strategies to drive growth and retention. So there are 2 files. There's the apps.csv, which contains all the details of the applications on Google Play, and it has 13 features or 13 variables that describe the given app. And then there's also the user reviews, and the user reviews contain 100 reviews of each app. And the text in each review has been pre-processed and attributed with 3 new features. That's a sentiment. So whether the review was a positive review, a negative review, or a neutral one, right? And then sentiment, polarity, and then the subjectivity of the sentiment. So first of all, open them in Excel. Okay, so this is the apps.csv. And our good old Excel, right? So there's this column here that I guess we're just using to number the columns. But then the most important ones are the app, the name of the app. I don't know if you recognize any app that you know over here, right? And then we have the category, the ratings. So we know that ratings is on a scale of 1 to 5, right? The reviews. So these are like IDs to the reviews. And then the size of the app, I think in megabytes. Yes. The number of installs, the type, whether it's free or paid, the price, the content rating, the genre, as in like the theme of it. And then when it was last updated, and the current version. And then like the Android version it is, right? So based on the graphs and the charts and stuff we've made, right? And we're trying to remember that the question is that we're trying to look for insights in the data to devise some strategies to drive growth and retention, right? So what are some of the questions we can ask, even just based on this sheet, based on this CSV file? Correlation between the number of installs and the ratings, right? So maybe the number of installs and then the number of 5-star ratings or 4-star ratings, right? Okay. Wait, I think, okay. Relationship between, let's all take notes of this, okay? This is the interactive part. Let's all take notes of this, because after this, I'll let you go back and we're going to think through the kind of visualizations we can use, and then you go back and try this after your labs. So relationship between the price and number of installs. Okay. Okay. We can look at distribution of how many apps have like 4-star, 5-star, 1-star, 2 stars, right? We can look at all those distributions, and we can put them on box plots, since they're like different variables, right? Instead of just using one histogram for a particular variable, we can look at all of them. Okay, so in the real world, when you discover that there are certain questions you want to ask, but you don't have data that can help you to answer, then you go back to the stakeholders or whoever is involved with that kind of data and see if you can actually get that data to come and use and bring out all these stories, right? So it's not just the data you're given, you can also look at external data as well, if it's available, right? You can also look at external data. So a classic example in like the work I do in insurance, apart from asking people for, let's say, home insurance, right? Apart from asking, okay, how old is your house? What material do you use to build? Do you have a dog or not? Apart from asking all those questions and using that data, we also realized that in the US, some places they have hail, right? The weather conditions can destroy your roof. So we actually have this variable called roof score, which is from a company called Verisk. So they take pictures of people's roofs, like with satellites, and they're able to classify them into whether it's a good roof or bad roof based on a certain score they give. So my company will not be able to come up with that data. So we realized that it's an important variable we need. So we go to pay for it from Verisk, which is a provider, right? And they give us those scores, which we also use in our models. So let me quickly like round up. The notebook is available. So I want you to think of graphs, the type of graphs that you can use, right, to answer these questions. So we saw that correlation stuff was more of the scatter plots, right? Scatter plots of if we have two numeric variables and want to see what kind of relationship they might have, we can visualize them with the scatter plots, right? And then finding the most popular categories, we could use the bar charts so that we see the tallest charts, right, among different categories. The most downloaded or the least downloaded app as well can be found. We can see it with that, right? Even the pie charts could help us to see that also in a way, right? So the notebook is available. It has like all the instructions to go through. I know you've done a little bit of Python, a little bit of NumPy, but probably a little bit of Pandas. But I know that in your hands-on session, you're going to do more, like you're going to get more of the practical skills, as in like the code to type. So this is a very interesting problem. I'm sure you can all tell that it's a very interesting problem to solve. So I'm going to leave that to you to kind of like read through and then still continue thinking through the kind of questions you can ask, the kind of graphs you can come up with, right? And even in EDA, so there's a whole lot with EDA. I didn't mention that there's a whole, like, you have to do data cleaning, in case you have duplicates, how you drop them, in case you have missing values, how you would deal with them, in case you have certain let's say certain data types are not right. For example, the price of an app, right? In order to do computations with it, it has to be in a float or in a decimal data type. But if it's in like a string or in a text format, you might not be able to do much with it. So how to even transform or convert the data type to the right data type that you need. So when you go through, I know that your hands-on session will go in depth into some of these things, right? So after you do that, you can come back to this and ask more questions and try out the visualizations that we've looked at. And then also, you can also search online to see if you can find that data. So there are sites that have some data sets like Kaggle, Zindi, and all that. So you could also, if you're interested in this particular program or this particular project, you can further look into that, into maybe how, if Google makes that data available somewhere through an API or something, how you can also incorporate it into your data and all that. So this was just an overview. This is just an overview of like the whole where visualization comes in, how or why you need to look at your data visually and not just depend on the mean, mode, and the statistical, the summary statistics, right? And all of that. And then also how to ask data story questions and how to answer them. So this was an overview. When you get your practical tools, like when you get the practical skills ready, you'll be ready to come back here and come and apply all that knowledge to solving some of these questions or answering some of these questions. I hope you like this session. Yes, thank you for your attention.